Advent of Code 2024, day 13, claw contraption. The whole thing is set up to be like one of those claw machines where you have to move the claw over the prize and get the prize. But really, this is for challenges a bunch of linear equations. So I've got button A that moves the claw 94 forward in X and 34 forward in Y. Button B moves at 92 in X and 67 in Y. My goal is to get to 8400, 5400 with some number of button pushes. They give us some things here. We need to calculate for each of these machines the number of button pushes that'll get us to the goal. Some machines won't be able to get there, so like button, I believe it's 2 and 4 in this one, just to have no solutions, at least for part 1. Those are okay. The ones we have to get as many prizes as we can, so solve all the machines and do it in the fewest cost possible. They tell us that pushing the A button costs 3 tokens and pushing the B button costs 1. Now, I can tell you right now, just looking at the math of this, that there's not gonna be a need to minimize. There's only gonna be one solution for each of these challenges. So anyway, we need to just figure out the total cost to get all the prizes we can. This is going to be a set of linear equations. So look at the first machine here. 94 times A plus 22 times B equals 8400, and 34 times A plus 67 times B equals 5400. So we have 2 linear equations and 2 unknowns, number of A and number of B. Those are going to solve out to a single answer. We'll need to validate that answer. If it's an integer, that means it's a valid solution. This machine right here has no valid solution, but it will have a solution. It'll just have a non-integer solution, and we can't push a button 0.3 times, right? So that's why it doesn't make sense. And then it does tell us somewhere in here that we can make a constraint that we're going to push a button no more than 100 times. I don't think that's going to matter. I'm guessing that's for people who are going to try to like step this through and not solve it with math. We're going to solve it with math. I think it'd be pretty easy to import a library like SymPy or NumPy and have it give it the equations, say solve the equations, give me the results. I was doing a little Googling to figure out how you do this manually, and I came across this page called Cramer's rule. Let's see. And here, this is exactly the situation we have. So we have, in this case, what I called A and B are X and Y, and what I call like the numbers that we have for the problem are A1, B1, B2, A1s, the A's, the B's, and the C's. So if we parse A's, B's, and C's out of our text, we can then come down right here and calculate X and Y using these equations. I think this is actually pretty simple to do. I'm going to pull this off on my other screen so I have it for reference, but we will take a look at it. Let's go ahead and get into VS Code. I will run my GenDay script here for day 13, and that is going to create pull the input for me, create a stub Python program. It's also going to give me a place to store I just recently added this. So now it creates the example.txt file that I can paste this into. Let's see. And so we'll put that right there. That looks good. Let's take a look at the input. Each puzzle takes 4 lines. And so we have, let's see, 1280. So divided by 4, let's see, 1200. That's 320 puzzles to solve. I think this should be pretty easy. Let's take a look. So what are we going to read in here? We're going to read in puzzles equals f.read.split on double new line to give us each puzzle. Then let's make def solve puzzle. I'm just going to do this all as one function. So puzzle will be a string, and we're going to return an x and a y, which will be a tuple of int. That. All right, the first thing we have to do is get our input parsed. I'm going to grab this right here. Come here. Put that there. Let's tab you in and comment you. Comment you? Comment you? Why are we not commenting? Okay. Not sure what's going on there. So basically, I feel like we could do some crazy splitting and stuff. This feels like a good use of regex. So we can say, I'm going to use the form from the Cramer's rule article. So I'm going to have A1 A2 is equal to re.findAll. And what I'm looking for here will be button A colon X plus, and then here's our digit, one or more digits, comma, Y plus digits, and that should be good. I think I need to, this plus is an actual plus, so I'm going to escape it. And then find all is going to return for each thing it finds, it's going to return a tuple with the different match groups. So I know I'm only going to find one thing, so I'm going to just go ahead and get the first thing, and then the tuple will map into this A1 to A2. Okay. Now I can do the same thing here and get B1, B2 equals for button B. And then get this and do C1, C2, and this one's gonna be slightly different. We'll do prize. I can type prize. And this is equals and equals like that. Now for Cramer's rule, I'm just literally going to type in this right here. So that is going to be X is equal to C1 times B2 minus B1 times C2, and that is over. And I just like, I think, I'm sure you could do this with some order of operations, but I just like to very explicitly do this. A1 times B2, don't need you, and this is B1 times A2. I'm going to copy this because I don't think Y is that different. And now I'm going to just change this to A1, C2, C1, A2, and the bottom is the same. So now I need to do some validation. So I can say if int x equals x and int y equals y, and 0 is less than or equal to x is less than 100, it was less than or equal to 100. I think it was less than or equal to, and I don't think this is going to matter, but 0 is less than or equal to y is less than or equal to 100. Return tuple, return, I guess we just return xy. That. Else, we're going to return 0, 0, because we're not going to spend any, if it's not solvable, we're not going to spend anything on it. So we don't need to push any buttons. So X is the number of times we push the A button, and Y is the number of times we push the B button, which again is confusing because they use A's and B's completely differently in the article, but I'm going with this for now. So I can come down here and I can say, let's see, let's do a test here. Part 1 equals solve puzzle on puzzles sub 0. Python day 13 example. Find all missing positional argument string. Okay, it helps if you add in puzzles. Puzzle. Grab you right there. Copy. Copy right there. All right, let's see what else we can do. Oh shoot. Okay, so right now I'm getting, these are all strings because that's what I'm matching on. So I need to do a tuple map int. Boom, boom. So now I've taken each object in this list, converted it to an int, and then converted that resulting map object, which is just a generator, into a tuple so that I can actually assign it. And then I need to do this. Missing even out my parentheses. Okay, let's try that again. So if I try that again, map must have at least 2 arguments. I should do int and int. 80 and 40. Okay, that's what I'm starting to think here. So I should do tuple map int on that. 80 and 40. Sweet. Okay, so that is what I got in the where's it? So 80 and 40. So that matches. All right, let's solve. Solve, I just need to, we're going to say part 1. I'm sure I could do this in list comprehension, but I'm going to say part 1 equals 0. Say for puzzle in puzzles. A comma B equals solve puzzle, puzzle. And then we can say part 1 plus equals a times 3 plus b. So now if we solve this, we get 480. That sounds reasonable. 480. Beautiful. Let's go back here and give it my input. Get a nice number. We got it. Let's go to part 2. Let me give me a pause to read. Okay, so in this one, our x and y's are off. We have to add this, I don't know what this is, a gazillion, whatever it is, this huge number to each the x and the y values, and we're going to push the buttons a lot more times, thus eliminating the brute force of stepping through it. We're allowed to go more than 100 presses to do so, and the challenge is otherwise the same. I think this can be very easy given where we are. Okay, I want to refactor this. So if we say offset int equals, better get that number. I don't want to guess at that. There. I also am going to, I'm going to try to eliminate this because I don't think it's necessary. So let's see if our input is still the same. Okay, so that didn't, part 1, still good. I've just added in the offset. The other thing we can do here is we can say C1 plus equals offset, C2 plus equals offset. Again, done nothing different. We should still have, oops, let's see. Make this 0 by default. Yeah, there we go. That makes more sense. So now we're still just solving part 1, but we've updated our thing so we can take an offset and solve it. So for part 2, we're going to say part 2 equals 0. And then down here, we're going to say A2, B2 equals solve puzzle, comma, offset equals, and now is where I need that number. So let's go back here, copy U, paste in, and we will say, grab U, boom, make that a 2. We can eliminate U, and let's see. I don't even think they gave us, ooh, that's certainly not right. Did not expect to come out the same. Oh, wait, that's just because I didn't do A2 and B2. There we go, much bigger number. Do they give us, I don't think they gave us an example. They didn't even give us, so we're just gonna go in blind here. But we get a large number quickly. I mean, this solves instantly because it's just math, and we're done. So anyway, that's the challenge. I think this was a pretty easy one, honestly, for this late in the competition, which is fine. But you know, we could have easily, this is the Cramer's rule stuff. I will include this on my here. Having some NumPy calls or some SymPy calls here would be just as easy, although I like not having to create a virtual environment and install those packages. So this is just, and this is really not hard. So thanks for hanging out with me today. I will be back tomorrow. Talk to you then.